Gate CSE 2018. Let a circle with a plus inside and a circle with a dot inside denote exclusive OR and exclusive NOR operations respectively. So the first one here, the symbol denotes XOR operation. The second one denotes XNOR operation. Which of the following is not correct? Four options are given. We need to identify one of the incorrect statement out of the four. First, let us check with the option A. Option A says that P XOR Q, the whole bar, equals P XNOR Q. That means perform XOR between two variables, then complement the result is equivalent to XNOR operation. This is obviously true. XNOR is the complemented version of XNOR. So even if you verify with the truth table, it says that when the inputs are different, output is high in the case of XOR. When the inputs are same, then only the output is high in the case of XNOR. So obviously XOR and XNOR operations are complement to each other. So option A is valid. Coming to option B says that performing XOR, but this time complement only one of the inputs. Then it is equivalent to performing XNOR operation between the two variables. Now let us verify this with the help of a simple table. Take P and Q as inputs because there are two variables, four combinations we have listed here. First, let us consider the 0-0 combination. Because we are complementing this P here, it becomes 1. So 1 XOR 0, if we perform, it becomes 1. Similarly, this becomes 1. If I perform XOR here, it becomes 0. Same way, complementing this becomes 0, 0 XOR 0, 0. And this becomes 0. So 0 XOR 1 becomes 1. If we compare with the XNOR operation, which claims that when the inputs are same, output is high. When the inputs are different, output is low. So the operation is very similar to XNOR operation. We can claim that option B is also valid. Complementing one of the inputs of XOR operation is equal to XNOR operation. Let us check with option C. Option C says that complementing both the inputs of XOR operation is equal to uncomplemented version of XOR operation, they say. Now let us check. Here it is 0, 0. Complementing both means 1, 1. According to the definition, when the inputs are same, output is going to be low in case of XOR operation. Here also, if we complement, it becomes 0, 0. 0, 0 also produces 0. Complementing both the input means this becomes 1, this becomes 0, producing high. In this way, either you perform uncomplemented version of XOR operation or complementing both the input variables, then performing XOR operation gives you the same result. So option C also a valid one. Now let us check fourth option, which claims that P XOR P bar, again XORed with Q. So in this situation, P XNOR P bar XNORed with Q bar. Now let us check this one. Here P XOR P bar, let us take the term inside the bracket first. P XOR P bar means according to XOR definition, when the inputs are different, like P and P bar, performing XOR will give you logic 1 as output. So let us try to simplify this. Once you make it 1, the remaining term is XOR Q. Performing XOR with 1 will give you complemented value of another input. If Q is going to be 0, output will be 1. When Q is 1, output will be 0. This is what operation of XOR gate is. So it is acting like a NOT gate when one of the inputs is high. So simplifying the LHS, we are getting Q bar as the expression. Now let us try to simplify right hand side. P XNOR P bar. Again, P XNOR P bar means a variable and its complement. That means 0 XNOR 1 means what will happen? The output is going to be 0 because when the inputs are different, output will be low. So this particular expression P XNOR P bar simplified to 0. Now take 0 here and consider the remaining set of operations. So XNOR with the Q bar. XNOR with the Q bar, if we do, it should be equivalent to Q bar according to left hand side. But if you verify here, 0 XNOR Q bar, let us try to prove it with the help of a table. Here is my P, here is my Q. Take one of the inputs as 0. So according to this situation, I'm considering one of the inputs as 0. Then Q can have two possible values, 0 or 1. Complementing the Q, we get Q bar as 1 and 0 respectively. Now perform XNOR operation between 0 and 1 because inputs are different, output is low. Now perform XNOR between 0 and 0, output is high. This is the result for P XNOR Q bar. Now check which one it matches with. Does it match with the Q bar or Q? If you compare, P XNOR Q bar is equivalent to Q. So in the given expression, it should be equivalent to Q bar, whereas the actual result is only Q. Accordingly, we can say that option D is invalid.